Good afternoon, everyone, and welcome to our webinar today of re-engineering obsolete PCBs. My name is Ed McMahon, and I am the CEO of Epic Engineered Technologies. As most of you know, we're a 60-year-old company, and we're a leading supplier today of printed circuit boards, custom battery packs, cable assemblies, and user interfaces. Our webinar today, again, titled Re-engineering of Obsolete PCBs, was picked because of the challenges that there are and that we see today with many customers who have to re-engineer their PCBs from scratch, whether it's just a lack of internal documentation or a cost reduction or whatever other reason it is. Re-engineering printed circuit boards is a very big part of our business, and we felt that while it sounds like it's a very easy process, there is an awful lot that goes into re-engineering PCBs. So the goal of this webinar is to give everybody the tools to understand what it is that we would need to begin the process so that we can most effectively do the re-engineering of the printed circuit boards. Our presenters today are from our partner FreedomCAD, who's got substantial experience in doing this type of process. As a matter of fact, I would submit to you that there's probably not a better organization in the country than these gentlemen. The first gentleman is Scott Miller, and he's the Chief Operating Officer of FreedomCAD. He's got over 35 years in this business. He spent stints with DuPont, Litton, and Teradyne, just to name a few. Along with him is Don Duncan, who's the Chief Technology Officer, with, again, over 35 years in the electronics industry. Don was also at Selectron for a while, and he was at Texas Instruments. So these gentlemen have some substantial experience in providing this re-engineering services. And again, our objective today was to make sure that as you're going through this process of re-engineering a printed circuit board, or even a full end product in general, that a lot of these concepts and a lot of the things that Scott and Don are going to talk about are specific to making sure that the process goes smoothly. So what we're going to do is, as normal in these webinars, is Scott and Don are going to go through the presentation. If you have any questions, go ahead and use the questions box in the bottom of your control panel, and then we'll go ahead and we'll pick a couple of questions at the very end to answer. And any questions that don't get answered, we'll go ahead and have Scott or Don email that person back directly with the answers to your questions. So without any further ado, I'll turn this over to Scott and Don and get into the real heart of the presentation.
Thanks, Ed. Appreciate that, and Don and I are looking forward to presenting to the group, and thank you all for joining this webinar. As Don said, as Ed said, the focus of this presentation really is to try to provide our experience on what makes a successful process of re-engineering a printed circuit board. And we're going to talk about the business-related issues, the technical issues, the importance of defining the scope of work, and in the case of many of our past re-engineering projects, adding features to the product because you are in the process of a redesign. And I'm going to share a few case studies with you that these are actual projects that we've worked on. We have, as Ed said, we have a varied background within our corporation. We provide electrical engineering, mechanical engineering, signal integrity analysis. We can do translations from one tool to another. Our really strength is in printed circuit board layout, and we roll all that up into how we analyze and look at re-engineering efforts. As Ed said, this is an important aspect of the design process that we're seeing because customers are faced with different challenges and consider re-engineering for a variety of reasons. There's cost reduction reasons, there's component obsolescence reasons, or obsolete technology, things that are being done differently today than when the product was originally designed. There's changes in standards, so there's standards compliance issues. And there's fundamental yield problems where the existing design just isn't yielding as effectively as was originally planned. So again, to play off of Ed's comments, our desired outcome is really to provide you with a better understanding of what information is required for us to provide an effective, accurate quote of a re-engineering effort. So if you're like most customers, you're challenged with the requirement of going out and trying to find somebody that can help you tackle this re-engineering effort, a redesign effort, because your engineers are all focused on the development of new technology and you're creating your differentiation, yet your income is coming from your old products, which are under price pressure. And you're trying to find ways to extend the life of that product or deal with obsolete components, whatever the obstacle is that you're trying to fight. Typically, there isn't enough bandwidth within the organizations that we work with to tackle both the development side of the equation as well as this sustaining or side of the equation. So to start with, really what we see as an important aspect of this process is to really start to qualify the return on investment for this process. And there are a number of elements that you have to take into consideration, none the least of which is your time. If you're going to have to invest in this process, both not only monetarily, but also from a time standpoint. Your effort and your investment into this effort is really going to be a component of the success of the project. Do you have the time to support the interaction that it will take? Because throwing it over the wall isn't going to yield a successful process. We've struggled with that with other customers and along the way, and when the light finally goes on is when we start to make the progress. Also, you have to look at what's the life expectancy of your product that you want to redesign. Does it have enough volume to recoup the investment that you're going to need to make, again, both in time and money, to make that change? Obviously, getting a proposal is part of that question, but having an idea of what your projected life expectancy for the product is going to be a cornerstone to making that decision. Do you have IP ownership? And by that we mean, do you have the rights to actually affect all the elements of the design that you're looking to re-engineer? That's an important criteria, and we bumped into that as a stumbling block along the way. We'll talk a little bit more about that. Does the product include any reference designs from a third party that would gate the effort? Again, this kind of reflects back on the IP rights. We're seeing more and more customers that are using embedded pieces of different suppliers' designs, and they're part of their solution. And so as you go forward and start to analyze what could change, what you'd like to change, you have to kind of take a step back and say, okay, what do we own and what do we incorporate that we don't own? So use that as a check step for yourselves to look at the design. Does the reference design contain any protection in the programmable devices that would prevent copying? Are there things that your partners, your suppliers have done with their components that would prohibit you from aligning it to something else? You need to check your NDAs. You need to make sure that things that relate to the re-engineering are meeting the requirements that you started down the path with in using the product. Do you have a functional specification available that defines all of the modes of operation? And by that we mean the environmental operational conditions, the storage conditions, any agency certifications. As we look at re-engineering the product and we try to develop a proposal to do that, we have to understand what requirements are included, because oftentimes we're focused on one small part of a larger system requirement in a particular printed circuit board, and so we need to understand how that's impacted by all of the influences that are in the design. And again, we'll talk a little bit more about that. You're going to need to do some homework, and you're going to need to be able to develop the current product's cost data. In order to understand the impact of the design on your bottom line, we're going to need to know what the costed bill of material is with the manufacturer, the existing manufacturer, manufacturer's part numbers, and the unit prices. That gives us that benchmark that we need. We're going to need the current actual unit cost, including the assembly labor, and that's oftentimes hard to get depending upon if you're outsourcing it 100%, then it's probably not that hard to get because you know what you're paying for a particular card. But if you're building it internally, you're going to have to do some homework to understand what your costs are, so that you can look at the cost alternatives with a intelligence. It would be ideal if you had a cost target in mind. The cost target and also the projected product volumes for the product will help to define the type of approach that's taken. For instance, if we can shave a penny or two off a component cost, that may play significantly on a very high volume product. But if it requires some other processing step in order to do that, it may not be as valuable to you. On the other hand, there's just a series of trade-offs by understanding your target costs and your projected volumes that go into the engineering effort to most successfully address a re-engineering effort. In general, all of this information really it provides us with the benchmark opportunity or benchmark information that we need for comparing the new alternatives to the existing costs, and that's really what you're going to be looking for in making the decision. From a technical standpoint, we're also going to need to have any of the documentation related to the existing product. So the existing product schematic, it can be in a PDF form or it can be in the original native schematic, but we're going to need that data up front to help us understand the complexity of the design and the requirements so that we can kind of get our arms around the challenges that we're going to face in identifying solutions for re-engineering effort. We're going to need the documentation or user's manual that provides any user interface information. Again, this is an area that you don't really think about, but as we're trying to define a solution, a re-engineering solution, we need to understand how you're going to be touching this product, whether it's being in installation or testing or the customer, if there's an interface with a customer or a technician, all those things have to be taken into consideration and be part of the re-engineering strategy. Ultimately, we're going to need an existing product sample to be able to kind of measure up the actual new design versus the original design. We don't really need that in order to quote, but we do need to know that it's available and will be available so that at the end of the process, during the verification stage, we know what we can do to do the verification. So it is part of the quoting process. It's not required that we have it up front, but it is important to know whether it's available or not. Probably the most important part of the process is to really begin to nail down your scope of work. That definitely has become the stumbling block of many of the projects because we start out with one idea of what the scope of work is, and then all of a sudden it grows into, yeah, but we'd like to do this and we'd like to do that. And so we really would recommend a written statement of work to start the process with. It gives us, again, the benchmark of where we started, and if the scope of work grows as a result of the dialogue, it's documented. We can both go back to it and say, this is what we started, this is why we quoted what we quoted when we quoted it, this is where we're at now, and this is why it's going to either take longer or cost more money or whatever the case is as the scope grows. But clearly it's important to define the scope of the work and to do it in writing. It's in everybody's best benefit to do that. And we oftentimes get asked to start projects without a written statement of work, and we do try to push back to get our customers to think about this because it's such an important part of the consideration. So, those scope of work should include performance requirements. It also should include re-engineering objectives, such as cost. If it's a cost reduction, what's the cost reduction objective? If it's obsolescence abatement, we have to look at for how long is this product going to be in circulation. We don't want to trade one problem for another problem. Picking, you have a component that's obsolete today. We pick another component, and that supplier knows that in 12 months that component's going to be obsolete, and you have a 2-year or 3-year-old life cycle expectation. Are you going to be looking for functional improvement? Are there features that need to be added to this product that aren't currently there due to changes in technology that are out there today? Some of our projects are consolidations. It's taking 2 boards or 3 boards and turning it into 1 board, or it's taking multiple components and doing that in a programmable device like an FPGA. Does the shape have to shrink? Does it have to be smaller and or way less? Does it, what are the physical requirements that are now becoming part of your redesign effort? And then clearly we need to understand what standards requirements are there. Are there new compliance requirements? Just because the old product now is going through a respin, there may be new product requirements and compliance requirements that are in play, and we need to understand what they are. Since this is your marketplace, we really need to rely on your experience in these areas. Continuing on the scope of work, some of the things that you can take into consideration, that we would take into consideration, and possible options in the scope of work are investigating new technologies that can be implemented to reduce a product cost or improve a product performance. There's materials improvements. There's any number of different things that we can look into to try to drive cost out or improve a product performance along the way. We obviously can look for, again, the desired product expectancy. So we're researching at a very high level. Hey, we're looking for, we've had customers that come into us and say, we want to get in front of this problem. We want to give you the bill of materials, and we want you to scrub it and look for any future pending obsolescence issues, because we're considering making a design change, and we want to know if there's anything that we should take into consideration. That can be a standalone activity. We want to look at the existing manufacturing process that are required to build the existing board, whether it's the bare board or the assembly, and look for alternatives. We have customers whose products have been in circulation for 5 or 7 years, and now that's, they're trying to address obsolescence issues or whatever. There's a lot new technology out there that, whether it's in board fab, such as blind and buried vias and HDI technologies, etc., where we can actually leverage those new technologies with the right forethought and drive layer count reductions. And anytime you can take layers out of a printed circuit board, you can take cost out. We can drive through smaller technologies or new technology. We can drive what was a double-sided board or a through-hole board potentially to a single-sided assembly. And again, if you can drive an assembly to a single side, then you can drive cost out. And as I mentioned before, there's consolidations where you can take multiple boards and shrink them down into one board or a couple of boards, and that has a significant impact on the end product cost. We'll also look at the current assembly and manufacturing processes to identify new manufacturing processes that may yield better results. So it's a yield improvement process, and that can save you on what you're paying. Again, this has a lot to do with picking the right parts and making the design right, and getting more consistency in the design. And then we also can look at consolidations of components, of logic components, so that you're leveraging what's out there today and paying. You can pay maybe $8 or $10 for a component that's replacing $30 worth of components. So those are all things that you can take into consideration in terms of the scope of work options in engagement. Typically, as these discussions go on, they also include new product features. So again, think about, as you're engaging in a redesign effort, think about any of the issues that you're having or functionality that you'd like to add to the design, because it's a good time to do it. So catalog them, identify them, document them so that we can get our arms around those ideas, those concepts, and see if we can adapt them to the re-engineering effort. Again, we talked about physical changes. There's a push to smaller is better, and we see this all the time. So really define what your requirements are from a size standpoint so that we can identify if we can fit the solution on the board space available. And then look for any kind of packaging. We can also look for any kind of packaging opportunities, again, newer, better ways to do things. Maybe when you design the product, you expect it to be a 1,000 unit a year product, and now it's a 10,000 unit a year product. And so the packaging and the approach for manufacturing it is really not geared towards the volumes that you're tackling or planning to tackle. Finally, it's really important to define who will be doing the validation and final approval process. Typically, that's a joint effort between us and our customers, but it needs to be defined. And there are elements of the final approval that really are outside of maybe outside of our direct involvement. There's software that's related to the product, or firmware, or it has to connect to another piece of equipment. Those are perhaps out of the scope of the individual board that we're trying to re-engineer, and therefore it oftentimes requires that we work hand in glove with our customer to identify the approval validation process. So again, think about that and document that, and clearly try to make that part of your statement of work so that there's a clear understanding of expectations. Again, the whole idea here is to try to share with you our experience in this area so that you can go out for a proposal and get a response and get an accurate proposal in a time frame that's viable for you. And obviously, the most important thing is, if you move forward, you want this to be a successful process. So just to kind of recap here on some of the key takeaways for this session, it's really important to qualify the ROI. You know what your sales are or projected sales are. You kind of got to get your arms around what you think you can afford to spend in the ROI effort, this re-engineering effort, because we're both going to make an investment in this process, and it's important to see that you can recover that investment. By that, you really need to determine what your budget is, and this will also help passing that information along while you're probably thinking, geez, if I tell them what I can afford to spend, that's what they're going to charge me. It's just in your best interest to say, this is what my budget is, and if you think it's not achievable, and budget can be both time and money. If you don't think it's achievable, then you don't want to go through the investing in this process because, again, it's going to take some time and on your part as well. Clearly try to define the life expectancy. That will help you determine if the ROI is going to be there. Clearly define the scope of work with a written statement of work. That helps us have a benchmark, a point of reference, and it really helps us lessen the potential for scope creep, or at least unknown scope creep. Once we have a statement of work and we've reviewed your data, we really would like to recommend scheduling a conference call to confirm our understanding of the scope of work and address any issues. And it's really hard to put everything on paper when you're engineering, so those conference calls or webinars like this really help us to draw out some of the things that may not have made the paper. It's very usual for us to get comments like, oh, I forgot to mention, or I want to point out in this area that we really need to get this into consideration. Those are all very valuable, even in the quote phase, because it helps us define the complexity and the challenges that we may face, so that we can mitigate the scope creep. You really need to understand that, again, that you're going to be part of this re-engineering process. You can't really throw it over the wall. There are key elements of the existing product and its environment that we won't be aware of, and only you or your team will be able to answer. So, please understand that it is going to be an interactive process. The ones that are not interactive, somebody tends to be disappointed in the process. Let's put it that way. Your support is key in this area because it helps drive the efficiency, the cost effectiveness, and the success of the overall project. And the quality of your data as it comes in really is helpful at developing an accurate cost estimate, but also at the efficiency at which we can operate. Too often, as Ed mentioned early on, there's often the engagements start with, this is all I have, and I need to try to re-engineer that. Well, that's a challenge because we really don't know what went into the original design, so there's a lot of guesstimation that goes into trying to understand what the unknowns were that went into that design. So the quality of the data that you supply, gathering your information, going out for a quote with the best package possible is in your best interest because it will yield the most accurate and the most opportunity for success. At this point, I'm going to turn it over to Don Duncan. Don, as Ed mentioned, is the CTO at FreedomCAD, and he personally was involved in each of these re-engineering efforts and has a lot more detail to offer in terms of what went into the effort and what drove the effort and how we went about solving the problems for the customer. Don?
Yeah, thank you, Scott. And as we've tried to describe throughout the presentation, I tried to pick examples that were relevant to what we were saying and the examples we were using. In this case, it was a 16-port, 2 gigabit fiber optic switch for networking equipment. The original design had 2 assemblies and connections between the 2. It was not conducive to manufacturing. It was kind of expensive. So the customer wanted us to look at the overall product. The approach we took was to redesign, combine the 2 boards, and that drove mechanical changes. So we implemented mechanical changes in the chassis you see here, and it drove signal integrity analysis to verify that the signal and data rates, signal and data quality were maintained from the or better than the original product. And then we had to perform a thermal analysis. So you'll see the power supplies, the airflow was from right to left. The power supply sucked in air over the PCB and it expelled it on the left through the left-hand side of the power supply. Okay, Scott, remember the case study number 2. There's another design cost reduction and logic consolidation. It's a multi-service access platform, some telecom equipment. The original design was pin through hole, so we took that, reduced the board size and the area that the board took up, and took out the significant amount of cost in the board. We also refreshed the technology. They used 5-volt logic, so we converted from the old pin-through-hole technology into updated 3.3-volt logic and condensed parts into the FPGA. You can see the new Xilinx FPGA in the center of the board. The old design was a double-sided board. We took that to a single-sided SMT PCB assembly, and it was functionally verified with the existing products. We plugged them into the chassis and verified they operated the same as the previous boards. And then the designs were passed on to the customer to perform product validation tests in their labs with their equipment rack. This one, another cost reduction, logic consolidation. It was an ATE platform where there were 14 printed circuit boards that required pin-through-hole to SMT conversion and logic consolidation. The customer acquired the existing product from another OEM, and they didn't have complete documentation or the engineering background with the product knowledge. So my engineering team had to be very meticulous and detailed in going through the work to recreate the designs and the design documentation to meet the original performance requirements. So we had to use an existing system and take measurements and pictures of waveforms and then verify that to that performance of the new assemblies. And that was quite challenging. And this last case study, number 4, probably is the best example we have of what we can do to take cost out and re-engineer a board. The one on the right, the left, is the original PCB assembly. You can see it's pin through hole, and it has 2 daughter cards over on the right-hand side. This was a digital delay line. It had 8 I/O channels for a test system, an IC test system to kind of stagger waveforms and verify performance of the silicon. So the obvious problem was excuse me, let me back up. The issue that drove the cost, the redesign, was the availability of the pin-through-hole components. Most of the parts they were using on there were becoming obsolete in a very short time. So we took the logic diagrams, we condensed the logic circuitry, 80% of it into the FPGA. If you look at the picture on the right, there's a quad flat pack that's in the center on the left and the right. If you draw a line right down the center of the board, that's the equivalent circuitry to the original design on the left. So we condensed the logic. The analog to digital components are surrounding the programmable part, and there's some memory on the board to store data, if you will. And then we created the final results as we created a single-side PCB with double the I/O channels, and it costs less than the original design over on the left-hand side. And we maintained the form factor, got rid of the daughter cards, reduced the cost. For assembly is a single-sided PCB, if I didn't say that already.
Thanks, Don.
So that's it from me. Those are examples that we've gone through.
Okay. Thanks, Don. At this point, I'm going to turn it back to Ed for a second.
Great, thanks, Scott. While you look at the questions that the folks here have brought in, just a quick overview of some of the products that Epic designs and manufactures. Starting with custom battery packs, everything from lithium-ion, nickel metal hydride, and NiCad, flex and rigid flex printed circuit boards, whether it's high-volume consumer applications or high-technology ITAR. User interfaces, our newest group, we've recently acquired a company called Suncoast Digital Technologies down in Largo, Florida, manufactures many aerospace and military user interface products. Fans and motors, the most energy efficient fans and motors in the country are some of our fans and motors we have proprietary designs on. And as you see here, our design centers and technical support, as we talked about, Scott and Don have been doing what they've been doing for such a long time. When we have folks buy our products that have been doing it a long time as well, every one of these centers here, we've got an engineering staff waiting to help our customers, whether it's an on-site visit, whether it's a webinar like this, whether it's just a conference call. We've got the technical resources to help you with any one of your designs, whether it's a new or a redesign of what we're going over today. And I'll kind of turn it back over to Scott here to finish it up with some of the questions that he's seen.
Great. Thanks, Ed. And if you have any further questions, please submit them, and we'll try to get back to you if we do run out of time. Let's see. There's a question here. Can you elaborate on how you go about executing layer count reductions as a means of cost reduction? It's a great question, actually, and it's something that we do quite frequently. We have a number of examples of customers, working with customers to take layers out of existing designs, not necessarily changing the components per se, but literally just being able to redesign the architecture of the board so that we can drive layer counts out. And they're really driven by a variety of situations. In some cases, the boards have been around for a while. They've been designed with out-of-date design strategies, and we can use more current design strategies in order to generate more cost-effective solutions. We can take a board that was designed with a single-track technology between pads. We can, using the newer technologies that are much more commonly and widely used, we can go to 2-track or even 3-track per channel routing and clearly drive layers out that way. We had one customer that we worked with, was a telecom customer. They actually had 57 mature designs that had been around for a while, and they threw those designs at us and said, tell us what you think you can do. So we went through the designs. Again, they were designed with older technology. We came back to them with a matrix of what we thought we could do in terms of taking layer counts out. They then took a look at their product life cycles, and they said, okay, here's 10 that we'd like to go pursue because it looks like the products are going to be around long enough and have enough demand to make that cost investment. So we executed on that for them. We have also found that sometimes the customers have designed their products internally, and due to schedule pressures, sometimes the designs weren't designed as efficiently as they should have been, and they added layers to the design effort, and they were underutilized. But it allowed their engineering group the quickest path to a successful date to manufacturing. So we can take a look at an existing design and do a route analysis. We call it flow planning to see if the design can be optimized. Sometimes it's just a matter of we have, now that the product's in production, there's more time to do it right. But one example, again, just we do this all the time, but just one example was we had a customer, a telecom customer that had a 54-layer backplane, and we took a look. We flow planned the design. We took a look at it, and we identified that we could take 10 layers out of that design. And their calculations were that those 10 layers would save them about $1 million annually in board cost. At the same time, we were able to look at the product from a functional standpoint, from a signal integrity standpoint, and they had identified some weaknesses in the design. We were actually able to improve, through our analysis, we were able to improve the product performance. And not only did we reduce the layer count by 10, but we actually improved the signal integrity of the design and actually gave them more headroom for their noise budget. So they were very pleased with that design result. Not every product's a 54-layer board, and therefore, that's not where we spend most of our time. We have customers with 12 or 14 layer boards, and sometimes we can only take 2 layers out or 4 layers out. But again, it's just another avenue to try to drive cost out of a product, and something that can give, like in the case of the backplane, can actually perhaps even improve and give a product more headroom to live longer in its existence. Let me see. You mentioned a lot about investing in the re-engineering process. We're not expecting to get this for free, although that would be nice. Can you tell me more about what you mean about investing? I think I probably talked more about this after the question, but in general, really what we're looking for is, in many cases, is a list of the people in the organization early on, so that we can identify who has the background. We don't want to keep going back to the one person and then them being, having to spend a bunch of time in meetings. It really comes down to, if you can help us with the list of who it is, who's the knowledgeable resource within the company that would be the right person to talk to about any, these different specific items, like test requirements or customer interfaces, et cetera. So that's an important opportunity for helping the efficiency of the design, and something that we've learned over our experience as ways to try to streamline the process and help our customers get to the end result faster. I think we've gone well over our allotted time, Ed. I don't know if there's any other questions that have come in, but I just want to do a time check with you.
Yeah, we'll get to everybody's questions that we didn't get to answer in email. We'll reply back to everybody if we didn't get to them.
Okay. Well, again, this is Scott Miller and Don Duncan of Freedom Cat, and for those of you that participated, thank you very much. We appreciate being able to share our experiences with you, and if you have a need, please do contact Epic. We can work together to help solve your problem.
Thank you, everyone.